Hi, today we'll be talking about delta epsilon definition of a limit, or precise limits of a function as x approaches a constant. You usually have the statement, limit as x approaches c, f of x will equal L. This has the following definition. Given any real number, which is epsilon, it'll be greater than 0. Then there exists another real number, which we'll call delta. It'll also be greater than 0, so that if 0 will be less than the absolute value of x minus c, which will be less than delta, then absolute value of f of x minus the limit will be less than epsilon. The value of delta depends on epsilon, so we will start with solving epsilon is greater than 0 to be able to determine an appropriate value of delta when it's greater than 0. So for the problem, we have f of x is equal to the square root of 21 minus x. L equals 1, c will equal 20, and epsilon will equal 0.1. So, f of x minus L, the absolute value of that has to be less than epsilon. We then substitute f of x for the f of x we're given. So, 21 minus x minus 1, which refers back to L, is less than epsilon. This can be solved by doing negative epsilon is less than 21 minus x minus 1, or I can break it down as square root of 21 minus x minus 1 is less than 0.1, and square root 21 minus x plus 1, 0.1. Okay, stop there. So, from here, on this problem, we're going to add 1 to the other side, and you'll have 21 minus x, the square root of that, be less than 1.1. So then we're going to square each side, and you'll get 21 minus x is less than 1.21. From here, we're going to subtract 21, and you'll have negative x, 19.79, and then divide each side by negative 1, which will cause this to flip. That's the first value. Now to do this side, I'm going to subtract 1, and you'll have negative . And then you're going to divide each side by negative 1. So you'll have square root of 21 minus x, flip sign again, 0.9, then square each side, 21 minus x, 0.81, then subtract 21, and you'll have, and divide by negative 1. So your two values will be 19.79